Minions, MoNaCo here.
And Milks.
We are in a video on moles of stoichiometry.
We are knee deep in the chemistry world right
Yeah, we got a few videos left to do after this one. This idea, this concept, this skill that we're teaching you right now is really in service of doing some practice problems.
Yeah, it is. I mean, there's some vocab that we need to know, and there's some specific problems.
Empirical and molecular.
But that one of these problems exists all the time, almost every year.
And that's the empirical to molecular formula one.
Yeah.
Right, convert the two.
It's
So
always
we're going
around,
to cover a couple pages in your packet. We're going to cover the basic ideas first, and then we're actually going to do a kind of semi-complex calculation, stepwise.
Yeah, we're going to take this one calculation farther than you're going to have to.
Most likely.
Most likely, yeah. So,
except in our practice.
So let's do the vocab first in this piece. Empirical formula.
Mm-hmm.
We do need to know what the empirical formula is. It's not in the empirical force or anything like that.
Yeah, no.
Right? It's the simplest form molecule. And if we look at our little pictogram here in the middle, right, HO is the simplest form of H2O2.
Right.
Right? Reduced it down, so it cannot be reduced any farther. There's going to be a 1 in there or an odd number in there as far as the subscript goes.
It goes back to fractions and ratios.
Yes, it does.
You know, the ratio of hydrogen to oxygen is a 1 to 1 in the simplest ratio that it can be.
Right.
If you had H2O2, it's still a 1 to 1 ratio, but the molecule is bigger.
Right.
So that's the distinction between empirical and molecular formulas. One's talking about a molecule that's real in the world, does something that we're familiar with, and the other is just a
bare bones
condensation of it.
Right, and that really only helps us mathematically.
Yeah, and purpose-wise, it doesn't really do much for us except for later on when we're showing you one of these complex calculations, converting a percentage into a formula.
Right.
It helps there, but that's about it.
That's really all it does. So molecular formula is then the real world molecule.
Yeah, like I said.
It will be a multiple of some form of the empirical.
A whole number multiple.
Right.
Right. 2, 3, 4,
and
5
both of our
times.
examples here in our picture is just that.
Yep.
As a matter of fact, propane C3H8 is both a molecular formula and an empirical formula.
Because you cannot simplify the 3 with the 8. They don't have any common factors.
Correct.
The ratio of carbon to hydrogen is 3 carbons to 8 hydrogen.
Right.
You can't get any simpler than that. Because you can't get half or fractions of atoms and molecules. You can't do it. Can't have half a carbon.
That is one of the brilliant things, this whole number ratio that dealing with the numbers of atoms. That's what this whole unit is based on, and why this mole thing works.
Is that the atoms?
That number of atoms.
Is indivisible and et cetera.
There we go. So, on to the rules, if we will.
The rules. So how do I convert molecular formula to empirical formula, Mr. Mills?
We will simply reduce, by the greatest common factor.
Okay.
So here's a good example, right? Sugar, we all know this.
There's, C6H12, there's 6 carbon, 12 hydrogen, 6 oxygen, atoms or moles, however you want to call it.
Right.
The ratio 6 to 12 to 6.
Right, and so can you come up with now what my greatest common factor would be with 6, 12, 6?
Greatest common factor, 3 does work, 2 works, 3 works, 4 doesn't work.
No.
5 doesn't work. 6 is the greatest common factor. While 2 and 3 are common factors,
we have to just keep going.
We need the greatest common factor.
Right.
Because we're going to simplify this down to get the smallest whole number ratios.
Right. Well, go ahead and do it with 3. You're just going to find that you got to do it again.
You have C3H. C3H4.
Right. And then you go down by 2 again.
Right. Yeah.
So there you go.
So we divide each subscript by that greatest common factor.
Right. So 6 divided by 6 is 1.
12, 6, 2, 6, 6, 1. So the empirical formula, which is the smallest whole number ratio of the elements, is CH2O.
Right.
The molecular formula, which actually makes it a molecule of sugar, C6H12O6. Correct. The relationships in the subscripts, that's all there is to it.
That is it. And notice that it's fixed now.
And at the risk of oversimplifying it, this mini lesson is about the vocabulary, empirical and molecular. We know how to do greatest common factors from math class, but molecular formula, empirical formula is what you're going to see. Not find the greatest common factor of the subscripts.
True.
No, it's what is the empirical formula for the molecule that has the formula C6H12O6.
Right. So it really is a vocabulary thing with, unfortunately, a little bit of math tied into getting from one end to the other.
But almost fun kind of math. I like that.
I think I'm hoping, I got my fingers crossed right now, that it's a little instinctual.
Yeah, for sure.
At this point, right?
With my students, it was very much that.
Very good. Very good. So let's do this setting up the steps to get empirical molecular formulas from when I give you the percentages.
Right. So if your problem or paper says molecule is found to be X% carbon, Y% hydrogen and Z% oxygen.
We can actually get you there.
You can work back to figure out both the empirical simplest ratio and
The molecular.
the actual molecule formula.
Yes, we can, and we're going to do that.
And this process in a lab is exactly how every single chemical compound that is currently known had been figured out.
Right, this is it. And so we're going to lay down the steps, and we're going to do a problem. We'll call it a video. Ready?
100-year-old chemistry
Here we go. First step, we're going to assume 100 grams
in our sample.
so that I can easily convert those percentages right into grams.
Right.
If it says 36% carbon,
I can say, oh, 36
grams of carbon. Right. Because I assumed 100 grams. So there's the starting point. Assume 100 grams, so those percentages become grams.
Right.
Then I'm going to divide each of these grams by the mass of the actual element itself.
Right, so you'd know it's 36% carbon, so you'd say 36 grams carbon divided by 12.
Because 12 is its atomic mass.
We're converting to moles.
That's what it
Wow,
says. It does
using
say
the
that
gram formula mass.
It does. Now we're going to do that for everybody that's present.
So if there's two elements, you do it twice, three times,
You got
four,
it.
et cetera.
Let's hope we don't get into 4 and 5.
I know we won't.
All right. And then we're going to divide each of these calculated moles by the smallest mole value present in the previous step, because that's going to get us the answer 1.
That's going to get us the lowest common factor.
Which is 1.
Right.
For at least one element now.
Right. And a half or 1.5 for the others, which then we can then, work it out.
We'll work it out. So then the answers to this step 3 are the subscripts of our empirical formula.
So we are taking the percentage, dividing by the gram formula mass, basically, to get to moles and subscripts for the simplest ratio.
Right, and then moles, moles we divide by the smallest mole across the board.
To get to the simplest ratio.
And now we have that. The answers from this step 3 are going to be the subscripts for our empirical formula. There's just one little note.
If they're not actual whole round numbers,
we might have to double or triple.
Yeah, double or triple, or maybe fudge like
1.98 is real close.
We'll call
that 2.
Right.
But we're talking about like 1.5.
Right. That
1.5, I got to double it to get it to 3.
Okay.
So that's what this is there for, just in case we happen to run.
So the steps are a quick verbal rundown. Percent turns to grams.
Yep.
Grams divided by atomic mass to get to moles.
Yep.
Divide all the moles by the smallest one present to figure out the smallest ratio of the moles.
You got it.
Then the molecular formula is going to be
some version of
a multiple of those.
Right.
So there's 4 or 5 steps to these problems,
Really
which is why we're taking our time here.
Right, and I didn't talk anything about going back up into the molecular formula in this step.
Okay.
Just so you know, just on the writing on the board here.
Yeah.
But that's going to be part of what we're going to go through. But
Sure.
we don't see that all the time. No. So let's just see how it goes.
So here's a sample problem. Compounds found to be 61% by mass carbon, 15.3% by mass hydrogen, and 23.7% by mass nitrogen. What's the molecular formula if the molar mass of the compound is 59 grams per mole?
Excellent. So why don't you do these 2 and I'll do the next 2.
So the first step we always got to do is got to take those percentages and convert them into mass. So 61% carbon, well, we're going to turn that into 61 grams of carbon. Why? Because that is the fudge factor
100 grams.
that we're assuming a 100-gram sample.
If I assume 100 grams, that percent just turns right into grams real nicely.
15.3% hydrogen turns into 15.3 grams of hydrogen. And then for nitrogen, 23.7%, 23, oh no!
Just go below,
0.7 grams nitrogen. Okay, so grams. Let me give you a little space to work with here. So I can't move them.
Sorry, you do these. Go ahead, bring them
All right.
down.
So using mass to find the moles of each element. So now that I have the grams of each element, I'm going to convert that into moles by dividing by the atomic mass for each. So if I've got 61 grams carbon times 1 mole carbon over 12 grams, you got a calculator handy for me, Mr. Milks?
Sure don't.
Oh no, find one while I write this math
Of
out.
course I got it.
15.3 grams hydrogen times 1 mole hydrogen over 1 gram. The first one is 5.08
Now that's really pretty close to what?
moles carbon. That's really close to 5.
Yeah, but we'll leave it at 5.08 for now.
This one I know, that's 15.3 moles hydrogen. And the last one we had 23.7 grams nitrogen times 1 mole nitrogen over 14 grams. So that turns into 24% divided by 14. What do you get? 23.7 divided by 14. 1.69. So 1.69 moles of nitrogen. And if we were to stop here, I could use those as my subscripts, but the problem with using those as subscripts is that they have decimals involved.
Right.
And so we don't like this.
Right. So there's an easy way now to get this whole number ratio thing to work out. We're going to use these numbers, and then next step we're going to divide by the smallest of the numbers.
Right. Okay, so
So let me transform the numbers we just had.
right, write them over
We
again.
had 5.08 moles of carbon.
Yep.
Right? And we had
15.3.
15.3 moles of hydrogen.
Right.
And we had 1.69 moles of nitrogen.
All right.
So which one's the smallest? I'm going to say 1.69. So I'm going to go ahead and divide all of these numbers by 1.69.
This is a math trick to get simpler ratios. So let's see, Mr. Milks. Let me help you with the calculator here. 5.0.
Hydrogen, nitrogen.
That first quantity, carbon, 3.005. 3.0.
Great.
15.3 divided by 1.69, 9.053.
9.
9. You need me to punch that one in the calculator?
No.
One.
1. So beautiful. So now these are now our subscripts
For the empirical.
for the actual
formula.
empirical formula. So let me go ahead and write this empirical formula down right here.
So
I'm actually going to do it down here. You know, it says up there. I'm going to say C3
H9
N.
N. Okay.
Okay. Now this particular problem asks us to go one step farther,
To go to the molecular.
to go to the molecular formula. So I'm going to change colors.
And it gave us a hint earlier too,
True. Well, what I'm going to do is I'm going to do GFM first off.
to find out the gram.
Just the way we
learned.
learned how to do it before. So I got C is going to be 12 times 3 is 36. H is going to be 1 times 9, which is 9. And nitrogen I know is 14 times 1, which is 14. I add these up and I get 59 grams per mole. And the problem says
That the molecular formula for the
is 59 grams per mole. So this empirical formula is actually
molecular
that we
formula.
were talking about because this number came out.
Right.
Now, if they said that number was 118, I'd
would
say,
have
I would say 118 divided by my 59 I just got equals 2. Now I would
Multiply.
multiply this whole thing by 2,
So that would be C6H18N2.
which is just to give you, right? It isn't how this problem worked out, but that's how a problem could work out.
And when we're in class, we're going to stop at the empirical formula. in
I
our
think so,
practice.
yes, is the goal.
Pretty sure. So thanks for checking this one out. I think we got a little bit more to do. No? Just know that empirical molecular formula.
Yeah,
You
we
got to
gotta-
know.
yeah.
And you got to know the first 4 steps of this problem solving too. Percent turns to grams. Grams turns to moles. Divide all the moles by the lowest number of moles to get your empirical formula, which is the smallest whole number ratio of the elements involved
There
in
you
the
go.
formula.
So you need to kind of go both ways.
And trust me, Regents isn't going to say greatest common factor.
No.
It's going to say empirical and molecular. So
It's
you
gonna
got to know your vocabulary.
Yes.
Gots to.
Yeah, that's the whole game right there.
Thanks for watching.
See you guys.
2 videos left.
Not many.
Not many.
See ya.
4.